Question 28 says, consider the graph of the polar function r equals f of theta, where f of theta is equal to 1 plus 2 sine of theta in a polar coordinate system for 0 is less than or equal to theta, which is less than or equal to 2 pi. Which of the following statements is true about the distance between the point with the polar coordinate f of theta, comma, theta, and the origin? So the first thing that I'm going to do is I'm determining a little bit about this graph. So I'm going to quickly get a sketch of what this graph is going to look like. To do this, I'm going to create a table of values where theta is the input and r, or f of theta, is the output. We'll go from 0 to 2 pi. And we're going to find some values by substituting into my f of theta equation. And I'm going to plot them along a polar coordinate grid as I go. So plugging 0 in, we have 1 plus 2 times sine of 0. Sine of 0 is 0. 2 times 0 is 0, so this is going to give me a r value of 1. So at the angle 0, I have an r value of 1. I'll add my angles on my grid paper. At pi over 2, sine of pi over 2 is 1. So this is 1 plus 2 times 1, or 3. At pi, I have 1 plus 2 sine of pi. Sine of pi is 0, so 2 times 0 is 0, so this is going to give me a value of 1. At 3 pi over 2, I have 1 plus 2 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, so this is 1 plus 2 times negative 1. 2 times negative 1 is negative 2, plus 1 is going to give me negative 1. So actually at the angle 3 pi over 2, I have a negative radius. So that's going to put me up here on the positive y-axis. And then back at 2 pi, this will have completed a full cycle, so I'll be back to where I started. And so I'll have a radius again at 1. So the way that this is plotted is kind of going in this spirally motion. I am going to hit the pole here at some point. I do know that based off of what I know about this type of polar curve. And so let's see if I can figure that out. It's going to be sometime between pi and 3 pi over 2, and then 3 pi over 2 to 2 pi. It's going to hit that pole. So let's see if we can determine that really quickly. We want to know when the 1 plus sine 2 sine of theta is equal to 0. Quickly solving this equation, I want to know when sine of theta is equal to negative 1/2. I know on my unit circle that is going to be true at the theta values of 7 pi over 6 and 11 pi over 6. So I should probably add those in. I'll use a different color here. So between pi and 3 pi over 2, I have 7 pi over 6, which is giving me a radius of 0. And then 11 pi over 6, I'm getting another radius of 0. So that's kind of where that's going to hit the pole, kind of along that process. All right, let's read through some of my statements to determine which statement is true about the distance between the point with the polar coordinate f of theta and the origin. Okay, so statement A says the distance is increasing. Again, we're talking about the distance between the origin and the ordered pair that is tracking along the polar curve. So the distance is increasing from 0 to 2 pi because f of theta is both positive and increasing on the interval. I think this is true, right? So my first radius here, my first distance is from 0 to 1. And then that increases, this distance increases until I get to from 0 to 3. So that's a distance there of 0 to 3. So we are positive radiuses, or positive f of theta, and we are increasing. So I think A is going to be my true statement. I kind of want to read through these just to make sure I'm not missing something pretty obvious. So let's take a look at B. The distance is increasing from from 3 pi over 2 to 11 pi over 6. So we're talking about the point from this -1 to this 11 pi over 6 where it gets to the origin. So we're at -1, it's radius of -1, and we are not increasing, we are getting closer. The distance to the origin is getting smaller, so this distance is not increasing but decreasing, so that cannot be true. Question C is the contradiction of A. The distance is decreasing from 0 to 2 pi. Well, we know that that is not true. We said that that was increasing earlier, so I can't contradict what I just said. And then D says the distance is decreasing from 3 pi over 2 to 11 pi over 6. So that is true as well. From 3 pi over 2, we are here at -1, and we are getting closer to the origin. So let's see if this is also a true statement. Because f of theta is negative, that is true. My values here are negative here and decreasing. Okay, so that's not true. So if we're a negative value and we're getting closer to 0, we're actually increasing. So that cannot be true either. So our only remaining true statement is A.